Welcome, everyone. Today, we're diving into a highly practical walkthrough of initializing and building a modern Next.js web project entirely through Claude's CLI commands. By the end of this session, you'll understand how to orchestrate an AI coding agent to bootstrap, design, and verify your web applications. Let's get started. Welcome. Today we are looking at how to set up a modern Next.js web project using Claude Code. What exactly is this? It's a workflow where we combine standard Next.js scaffolding with Anthropic's powerful command line agent. Why do this? Because manually setting up boilerplate, configuring routing, and writing initial components takes valuable time. By running a few basic CLI commands, we can have Claude read our workspace, understand our Next.js app router setup, and start writing code for us. How do we start? We use standard npm commands to build the shell, and then let Claude take the wheel. Let's explore how to initiate this symbiotic relationship. This flowchart visualizes the initial setup. As a developer, you first run the standard Next.js creation script to generate the app shell. Once the base app exists, you launch the Claude CLI inside that directory. The agent immediately begins analyzing your codebase, establishing a foundation for the agentic workflow on the right. Before Claude can write our Next.js components, we have to get it running. What is this step? It is globally installing the agent and launching it in our project. The basics involve using the native installer, which handles all OS-specific configurations for you. Why run it locally in the terminal? Because Claude needs direct access to your file system to read, write, and lint your code. How do we start? Once you've spun up your Next.js dev server with npm run dev, open a fresh terminal tab and simply type Claude. Our deep dive here involves security. Claude Code will immediately ask for explicit permission to read your directory. Once approved, it begins a process called booping a deep scan of your package.json and next.js structure. Looking at the sequence diagram, we see the initialization handshake. The user types Claude into the terminal. Claude initializes and strictly requests file access permissions to ensure local security. Once the user approves, Claude begins its booping process, autonomously mapping out your Next.js file tree and dependencies. Now that Claude is running in our Next.js folder, we need to give it persistent memory. What is this? It's the /init command. The basics are simple. You type /init, and Claude scans your entire repository to generate a claude.md file. Why is this critical? Without it, you'd have to remind Claude that you are using Next.js, TypeScript, and Tailwind CSS on every single prompt. How it works is entirely automatic. In our deep dive, we see that Claude specifically identifies modern Next.js features like whether you are using the app router or the pages router. It locks those architectural details into its memory, so every component it writes tomorrow perfectly matches the stack you are building today. This diagram shows the /init command in action. It branches out to scan your package.json for dependencies, your TypeScript config for strictness rules, and your app router structure. It synthesizes all these technical details and outputs the claude.md file, which serves as the permanent, persistent project memory for all future interactions. With our environment set up, we introduce spec-driven design. What is it? It's the practice of defining what you want in a specification file before any code is actually written. The basics involve creating a memory directory with a spec file. Why do this? If you just tell Claude build a landing page, it has to guess your design, which leads to hallucinations. By writing a spec, we lock in the requirements. How? We can actually ask Claude to brainstorm and write the spec for us. For our deep dive, this is highly relevant to Next.js performance. Your spec can explicitly define which components should be React Server components for SEO and which need use client directives for interactivity, ensuring Claude builds a highly optimized React application from the start. This flow illustrates the spec-driven pipeline. We take a vague idea and ask Claude to draft a specification. We save this draft as a markdown file in our spec folder. The developer reviews and approves this architectural blueprint. Now, we are perfectly positioned for actual code implementation with strict, agreed-upon guardrails. It is time to write code. What are we doing? We are commanding Claude to build the Next.js components we just specified. The basics involve a simple prompt where we use the @ symbol to inject our spec file directly into the context. Why is this so powerful? Because we aren't just getting text back. Claude enters an agentic loop where it creates the files, writes the React code, and checks for errors. How do we do it? We prompt, implement the main page grid as specified in its spec/claude.md. In our deep dive, you'll see Claude actively create a to-do list in the terminal. It generates the TSX files, and crucially, if it makes a TypeScript error, it will read the compiler output and fix it autonomously before you even see the final code. This state diagram maps Claude's internal execution loop. It starts by reading the spec, then transitions to generating the next.js code. Crucially, it runs the linter. If the linter fails, it enters a self-correction loop to fix the TypeScript errors. Only when the linter passes does it reach the success state, ensuring your next.js build won't break. Let's look at an incredibly powerful real-time use case, UI automation with MCP. What is MCP? It is the Model Context Protocol, which extends Claude's capabilities to external tools. For our next.js app, we configure the Playwright MCP server. Why do we need this? Because writing React code is great, but we need to visually verify that it actually renders correctly in the browser. How do we add it? We use the Claude MCP add Playwright command. Our deep dive here is spectacular. Once installed, you can ask Claude to check if the homepage looks right. Claude will autonomously launch a browser, navigate to your local next.js server on port 3000, take screenshots, and visually verify the UI elements it just programmed. Here is the sequence for our visual testing use case. Claude instructs the Playwright MCP to visit the local server. The MCP pings the next.js app, captures the rendered HTML, CSS, and visual state, and returns it to Claude. Claude then analyzes this visual feedback to guarantee the front end looks exactly as specified. What happens when things go wrong? We use the rewind feature. What is it? It's a safety mechanism to roll back unwanted code changes. The basics are simple. You just type /rewind in the terminal, or press escape twice. Why do we need this? Because agentic coding is experimental. Sometimes Claude builds a next.js layout that simply doesn't fit your vision. How it works is seamless. You select a checkpoint from a menu. For our deep dive, you should know that before Claude executes any file modifications, it secretly snapshots your file state. If a complex routing update breaks your application, triggering a rewind acts as a localized time machine, instantly restoring your project files to their exact previous state. This decision tree represents safe experimentation. You prompt Claude, and it immediately takes a file snapshot. It modifies your next.js files. You reach the developer decision node. If you are happy, you keep the code. If not, you hit the red node, run/rewind. The system instantly restores the snapshot, bringing you safely back to the start to try a new prompt. Our final step is version control and best practices. What does this entail? It means securing the AI-generated next.js code using Git. The basics are your standard Git status and Git commit workflows. Why is this so crucial? Because version control is your ultimate safety net when working with autonomous agents making rapid changes. How do we do it? You don't even have to write the message yourself. Just ask Claude to commit these changes. Our deep dive reveals that Claude will autonomously run git diff, analyze the React components it just built, and generate a highly descriptive commit message summarizing the business logic. It's the perfect end to our workflow. Thank you for joining this session. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Happy coding! This final flowchart shows the commit lifecycle. From your working next.js app, files are staged. Claude reads the raw git diff, uses its intelligence to write a semantic commit message, and finalizes the secure git history in the green node. Your project is now safely versioned and ready for the next feature.